Welcome student. In this video, I'm going to discuss the derivative of function using chain rule. Suppose the function is y is equal to sine of x plus a. So we'll first differentiate this with respect to x. dy by dx is derivative of sine of x plus a. We know that the derivative of sine x is cos x. So here derivative of sine x plus a is cos of x plus a into by chain rule the derivative of this x plus a. So this as it is, and this is derivative of x plus derivative of a. Now derivative of x with respect to x is 1 and a is a constant, so its derivative is 0. So your answer is cos of x plus a. The second question, y is equal to ax plus b whole power n. Here this is a function of, this is just like x raised to the power n. We know that the derivative of x raised to the power n is n into x raised to the power n minus 1. So its derivative is n into ax plus b whole power n minus 1 into by chain rule derivative of ax plus b. This is derivative of ax plus derivative of b. Now further derivative of ax, derivative of a into x, as a is a constant, so you can take this a out from this derivative. So this is a into derivative of x plus derivative of this b. Derivative of x is 1 and b is a constant, so its derivative is 0. So your answer is a into 1 into n is an into ax plus b whole power n minus 1. Third question, differentiate this function with respect to x. Again you are going to follow the power rule, that is derivative of x raised to the power n is n into x raised to the power n minus 1. So this is 10 into x square plus 3 whole power 10 minus 1, that is 9 into by chain rule derivative of x square plus 3. This is further derivative of x square plus derivative of 3. Derivative of x square is 2x and 3 is a constant, so its derivative is 0. So this is 2x. 2x into 10, 20 times x square plus 3 into 9. Find the derivative of this function. So dy by dx is d by dx of sine of a, sine raised to the power nx. This is written as sin x whole power n. So first you are going to follow the power rule, like the derivative of x raised to the power n is n into x raised to the power n minus 1. So this is n. In place of x we have sin x. N into sin x raised to the power n minus 1 into derivative of sin x. I am again repeating. First apply power rule like x to the power n. This is n. In place of x we have sin x and into sin x raised to the power n minus 1 into by chain rule derivative of sin x. So this is n into sin x raised to the power n minus 1 and the derivative of sin x is cos x. Fifth question. Find the derivative of this function. Here you are going to apply first quotient rule, that is the square of denominator. Denominator into derivative of numerator minus numerator into derivative of denominator. So this is sine raised to the power nx into derivative of x is 1 minus x into, you have evaluated its derivative in this question. So from here I am writing the answer, that is first power rule n into sin x whole power n minus 1 into by chain rule derivative of sin x is cos x. So this is sine raised to the power nx minus x into n into cos x into sin x raised to the power n minus 1. And this is power sine raised to the power nx whole power 2. It can be written as sine raised to the power 2nx. Next question, find the derivative of this function. Again you are going to follow the quotient rule here. The square of denominator, denominator into derivative of numerator minus numerator into derivative of denominator. So your denominator cos x into derivative of numerator sine of x plus a minus numerator into derivative of cos x. In this function you are going to follow chain rule. Derivative of sine of x plus a. The first function is sine. Its derivative is cos. So this is cos of x plus a into, by chain rule, derivative of x plus a. Derivative of x is 1 and the derivative of a is 0, minus sine of x plus a into derivative of sine x is, derivative of cos x is minus sine x, and in denominator I'm going to have cos square x. And the last topic is the limit of these functions is the first formula, limit x tending to 0, e raised to the power x minus 1 upon x is 1, and limit x tending to 0, log of 1 plus x upon x is 1. In both the cases, here you have, in this case you have 1 and x is tending to 0. The first question, evaluate limit x tending to 0, e raised to the power 4x minus 1 upon x. Here you have 1. Now, this is 4x. So, you need to multiply and divide by 4. This is 4x. Here I have divided by 4. So, multiply by 4. Now, as x tend to 0. So, 4x will also tend to 0. So, this is 1 into 4. Your answer is 4. Second question, find limit x tending to 0, e raised to the power 2 plus x minus e square upon x. Now, for applying this formula, you need to have here 1. So, first, I'll split the power. E raised to the power 2 into e raised to the power x minus e raised to the power 2. From these two factors, you can take e square common. You'll have e raised to the power x minus 1. Now, limit x tending to 0, e raised to the power x minus 1 upon x, it will approach to 1. So, this is e square into 1. Your answer is e square. Evaluate limit x tending to 5, e raised to the power x minus e raised to the power 5 upon x minus 5. We know that in the formula we have limit x tending to 0, e raised to the power x minus 1 upon x. This is equal to 1. So, here in place of x, you are going to have x minus 1. So, I'll put x minus 5 equal to h, or x is equal to 5 plus h. As you are going to change the question from x to h, we are also going to change the limit. X is approaching to 5. If x is approached to 5, 5 minus 5, your h will tend to 0. So, this is limit h tending to 0, e raised to the power 5 plus h minus e raised to the power 5 upon, this is x is 5 plus h minus 5. This is 5. Cancel. So, you can rewrite this as limit h tending to 0, e raised to the power 5 into e raised to the power h minus e raised to the power 5. Now, from these two factors, you can take e raised to the power 5 common. This is e raised to the power h minus 1 upon h, and h is tending to 0. So, its value is 1. From this result, this is 1 into e raised to the power 5. Your answer is e raised to the power 5. Next question. Find the limit x tending to 0, e raised to the power x minus 1 upon x. This is our formula. Limit x tending to 0, e raised to the power x minus 1 upon x is 1. Here you have sin x. So, I'll divide by sin x and here multiply by sin x. As x approaches to 0, sin x will also tend to 0. So, that means it will tend to 0, and we'll also know limit theta going to 0. Sin theta upon theta is also equal to 1. So, limit x tending to 0, sin x upon x, this is also equal to 1. So, 1 into 1, your answer is 1. Next question. Limit x tending to 0, log of 1 plus 2x upon x. Now, the result is limit x tending to 0, log of 1 plus x upon x. This is equal to 1. So, here you have 2x, that means I'll divide by 2 and multiply by 2. As x approaches to 0, so your 2x will also tend to 0. That means this part is 1. Its limit is 1 into 2. 1 into 2, your answer is 2. Last question. Limit x tending to 0, log of 1 plus x cube upon sine cube x. You have here x cube. So, we'll divide both numerator as well as denominator by x cube. Now, as x tend to 0 in this formula, limit x tending to 0, log of 1 plus x upon x is 1. As x approaches to 0, x cube will also tend to 0. So that means this factor will also tend to x cube. This factor will also tend to 1 using this result, because your x is tending to 0. So x cube will also tend to 0, right? So this limit will tend to 1. Now it can be written as sin x upon x whole cube. We know that limit theta going to 0, sin theta upon theta is always equal to 1. So this is also equal to 1. So 1 upon 1, your answer is 1.